myself Dr. Preeti Chakwani, Department of Computer Science, Arbit College, University of Delhi. So in our previous lecture we started with the topic of network topologies. We looked into what actually a network topology is, which is kind of a we can say geometrical representation of the layout of different nodes connected using the links. And we have looked into some of the topologies, like we have looked into point to point connections, then we looked into mesh and star topology. Moving further in the list, we have a few more we have bus topology, ring topology, tree topology and hybrid topology. So in today's lecture our agenda is to explore all these types of topologies. So with this let us move on forward. So bus topology, it is actually a network type in which every computer, or we can say every network device, is connected to a single cable. That cable or that connection is actually a bidirectional connection, and it is a multi-point connection, kind of a, we can say, non-robust topology, because if the backbone fails, the topology is going to crash. Now what does this topology, or how does this topology looks like? So that is shown on the screen. So on the the central line, which you can say is known as backbone, or the central cable, we can say, which is normally usually in the form of coaxial cables. We can use others as well nowadays, because of the technology advancements, we can use others as well. Now this central backbone is connected to all the nodes. If you can see here, we have node 1, node 2, 3 and 4, and all these lines which are, or all these channels, connections which are connecting the nodes to the single to that backbone are known as drop lines. So there is a drop line between node 1 and backbone, there is a drop line between node 2 and backbone, and so on and so forth. On the two sides, or on the two ends of the backbone, we also have two terminators in order to kind of prevent the signal loss. So this bus topology, as we have seen, is something in which every node or every network device is connected to a single cable, and the kind of communication, we can say, is bidirectional. That means the data can traverse from any of the ends of this bus or cable. Multi-point connection, I told you, non-robust because of the dependency on this backbone. If it fails, the whole topology crashes. This is also known as line topology. And in this bus topology or line topology, if we say what are the protocols which we are going to, protocols which are being used are, one is MAC, various MAC protocols we are going to use, which MAC here stands for Media Access Control Protocols, and also LAN Ethernet connection protocols like TDMA, Pure Aloha, CDMA, then Slotted Aloha. All these are names of protocols which will be looking into our further lecture. So these are the protocols which are used in bus topology. Figure I have already shown you. Moving further, let us look into the advantages of bus topology. Now if n devices are connected to each other using a bus topology, then the number of cables required to connect them is 1, which is actually the backbone cable. And yes, definitely n drop lines are also required, because I have told you that drop line is the line line of the connection between cable and the between the backbone cable and the device. What kind of network cables we can use here? You can use coaxial or twisted pair cables. Nowadays you can use some high end technologies also. So bus based networks generally supports 10 Mbps kind of data rate. Cost of cabling, if we talk about, is less as compared to other topologies, but the constraint here is that this kind of topology is used in order or in building small networks, because over the over a long backbone cable, signals may lose their strength, and then repeaters have to be kind of employed in. And bus topology is actually it's a kind of simpler technology in terms of installation and troubleshooting techniques if we talk about. And method which is most common method for the data transmission is SASMA, CSMA. Disadvantages, if we talk about, it is a simpler, but still it requires cabling, that means the backbone and the end drop lines are required. That backbone, if it fails, then the whole system is going to crash down. And if the network is heavy, because the whole transfer of data is relying on one particular cable, it is going to increase collision in the network. And because of this collision, we can use various protocols which are, we can say, pure aloha, maybe slotted aloha is going to give us some relief from the collision, or maybe SASMA CD protocols. Adding new devices onto the network is easy, but definitely it is going to slow down the networks. And because of this because of this multi point connection, security is kind of, we can say, is low. So this was basically ring topology. So this was basically bus topology. Let us now move on to the ring topology. So as the name indicates, it forms a ring connecting the devices with where each device is having exactly two neighboring devices. And here is the figure of this ring topology. So you can see device 1 is connected to device 2 as well as to device 6, then device 3 is connected to 2 and 4, and so on and so forth. So one, you can say in the simpler terms, you can say one on the left side, another one on the right side. So here, if you can see, it is forming a ring like a structure. So that's why it is known as kind of ring topology. So ring topology, if you are going to increase the number of nodes, large number of repeaters will be required. So for example, let's say we have 100 nodes, and someone wants to send the data to the 100th node or to the last node in this topology, then data will have to pass through all other 99 nodes in order to reach that last one, because data is going to be generally data is going to be we can say transferred in a single direction. So if it is kind of clockwise, let's say from 1 to 2, then 3, then 4. So if there are 100 nodes and one wants to send to data onto the 100th node, it has to pass through 99 nodes, 98 nodes to be precise, and then it will reach onto that destination. So in order to prevent the data loss, if the number of devices in the ring are more, then repeaters are to be used. Data, as I have told you, flows in one directional, but it can be made bidirectional, but by having two connections between each computer or between each network node, that is also possible. So it is called dual ring topology if you are using this kind of an arrangement, that is having two connections or having a bidirectional link between each and every nodes. And in ring topology, there is a kind of we can say the token ring passing protocol, which is used by all these devices or all these workstations in order to transmit the data. So what is this token ring passing protocols? I will just give you a kind of a very brief idea about here. So there is some token which is available, and the machine or the workstation which is having token will be able to send the message, and all others will have to wait till they get access to that token. So, most common access method is, we can say, token passing, kind of a network access method in which a token is passed from one node to another. It is kind of a we can say frame that circulates around the network, and the machine which is, or the station which is having that token, will be able to transmit the data. Others without the token will not be allowed to transmit the data unless they get hold of a token. One station can be called as a monitor station, and that monitor station takes all the responsibility for performing these operations, which is, in order to transmit the data, the station has to hold the token, and after the transmission is done, the token is to be released for other stations to use it. And if no station is transmitting the data, that token will keep on circulating in the ring. Now, if we go deep down into this token mechanism, there can be two types of token release techniques. One is an early token release, which releases the token, or the station releases the token just after transmitting the data. Another one is the delayed token release, in which the token is being released after getting an acknowledgement from the receiver. So, that is kind of techniques. We will be looking into this token passing protocol or this thing into details when we look into various protocols of computer networks. Looking at the advantages of ring topology, data transmission here is high speed, possibility of collision is minimum, we can say, in this type of topology, because all others who are not having token are not in a state to transmit. It is cheap to install and expand also, and it is also less costly than a star topology. All these are we can say advantages of ring topology. Looking onto other side of the coin, which are disadvantages, failure of a single node in the network can cause the entire network to fail. That is also a possibility. Troubleshooting is actually a difficult task as far as ring topology is concerned, and the addition of stations in between or removal of stations in between can disturb the whole topology, and because of kind of a multi-point connection, it is less on security side also. So, till this point we have looked into the bus topology, the advantages and disadvantages, also ring topology along with its pros and cons. Tree topology, if we talk about, which is next in the list, is actually a variation of the star topology. We can look tree topology as this also. This topology has a hierarchical flow of data, as tree is actually a hierarchical structure, you all are aware. What kind of protocols we are going to use? So, the protocols are DHCP, dynamic host control protocol, then SAC protocol, which is a standard automatic configuration. So, tree topology, if you want to have a look, here is the tree topology which is available on the screen. So, we have a device 1, on the next level it is having device 2 and device 3, and on the next level devices 4, 5, 6, 7 are present, and here you can witness one a tree like a structure. So, let us explore more about this tree topology. So, in tree topology there are various secondary hubs which are connected to the central hub which contains the repeater. So, there is a central hub, let us say device 1 here is the central hub, and there are various secondary hubs which are connected to this central hubs. Data flows from top to bottom as the kind of, we can say, structure suggests. Data flows from top to bottom as the structure is completely hierarchical, that is from the central hub to the secondary hubs and then to the devices, or it could be from bottom to top, that is from devices to the secondary hub and then to the central hub. So, here in this figure you can imagine that device 1, let us say that is the central hub, 2 and 3 are the secondary hubs, while 4, 5, 6, 7 are actually the receiving nodes or the kind of devices at the end. So, data may transfer from 1 to 2 and 3, and then from 2 to 4 and 5, from 3 to 6 and 7. And if the data has to be gone, that data has to be gone in the kind of from bottom to up. So, 4 and 5 can give their data to the secondary hub device 2, and then that secondary hub can transfer the data to device 1, or vice versa we can say. So, in this way data flows in this tree topology. As you can see, it is a multi-point connection, kind of a little non-robust topology, because if this connection between the hubs is going to fail, which is kind of a backbone, the topology is going to get crashed. Advantages, if we looked into, it allows more device to be attached to a single central hub, and thus it decreases the distance that is travelled by a signal to come to the devices. If all these devices are to be arranged in a different topology, the data has to travel a distance which is going to be more than the tree topology. And it also allows the network to get isolated, and hence it may prioritize the communication from different computers. We can add the new devices to the existing network easily. So, for example, at the end of or getting connected with secondary hub 2 is easy, we can attach directly a new device over there. And so is your error detection and error correction are also very easy in tree topology. Disadvantages, if we looked into the higher level central hub, for example device 1 gets fails, then entire system is going to be fail. Cabling is required, or cabling cost we can say is little higher, and if new devices are to be added, adding is easy, but reconfiguration is required. If we ask ourselves that which is the common example of a tree topology, then this could be a hierarchy in a large organization, which is at the top of the tree there is a machine which is handled by CEO, and that machine is connected, or that device is connected to the different departments or divisions, or the head of the departments or head of the divisions, and then those head of the divisions are getting connected to individual members of the department or divisions, which are the child nodes of the company. That means each department has its own hierarchy, with managers overseeing the different teams, and the team members, which are nothing but we can say leaf nodes, are at the bottom of the hierarchy, connected to their respective managers and departments and so on. So, wherever we are looking for a tree like hierarchical structure, the hierarchical structure of an organization is going to be the best aligned example of that. After looking into bus topology, then ring topology and tree topology, let us move to the next one, which is hybrid topology. Hybrid, as the name indicates, it is actually kind of we can say combination of some topologies, or combination of various types of topologies, and all these topologies we have already studied. So, we have studied point to point bus topology, then a star was there. Then we have looked into MASH, then we have ring topology and tree topology. Any of these topologies can be combined. So, hybrid topology is used when the nodes are free to take any form. It means that there can be individual clusters which are having a ring topology or a star topology, and these ring or star topologies can be combined in a single cluster. So, there can be individuals such as ring or star topology, or can be a combination of various types of topologies which we have already seen. Each individual topology uses a protocol that we have already kind of named earlier, we can say. So, here you can see here is a figure. So, on the left side of the figure we can see a small tree topology in which one central hub and then 3 secondary hubs or child nodes are there. Then we can witness just next to that on the upper side of the cable, we can have we are witnessing one star topology of there with one central hub in between. Then on the left, on the bottom lower side, we can witness one ring topology, and all these three topologies are connected, if you can see, with the help of a single backbone cable, which is forming the structure of a bus topology. So, here different topologies, which are tree topology, star topology and ring topology, are connected with the help of or connected using the structure of the bus topology. So, that is a perfect example of a hybrid topology. As far as advantages are concerned, it is flexible, and in order to introduce new devices, it is going to be easy. So, size of the network you can expand easily, but on the disadvantage side, if we look into it, is challenging to design the architecture because these are going to be hubs or internetworking elements which are going to use in this topology are very expensive. Infrastructure cost is on the higher side because lot of cabling and network devices are required. Common example in which a hybrid topology can be employed is a university campus network. So, maybe the administration is relying on a star topology, account section is relying on a kind of ring structure and so on and so forth, and this network may have a backbone with each section connected to this backbone using switch or router or any other appropriate internetworking element. So, internetworking elements we will be looking into in our upcoming lectures, and within this each building or within this each section, as I have told you, admin section, account section, maybe library sections, there may be bus or ring topologies or other topologies connecting the different rooms and offices. This can this can be in the form of a wireless topology. Also the wireless access points also can will be able to create a mesh topology, and then a hybrid topology allows for efficient communication between different sections while providing the flexibility and redundancy within kind of each building. Now, we have looked into the all important types of network topologies. Now, why it is why there is a dire need to look into or to take care of this structural arrangement of this or we can say why it is important to look into this network topology, because the network topology defines that how devices are connected and how they communicate in the network. So, choosing the appropriate topology as per requirement will help in running the network easily. It will increase the network performance. So, that means performance is kind of we can say yes, somewhat dependent on the choice of appropriate topology. Reliability, if we talk about, is another feature. Some topologies like star, mesh are more reliable, that if one of the connection fails, they can provide an alternative for that connection, and hence it can work as a backup. So, network, apart from network performance, network reliability is also a kind of point which is to be taken care by appropriate topology. Then scalability issues, that means how much expansion we can do in a particular topology. So, choosing correct topology helps in easier expansion of network. Easier expansion says you can add more devices to the network without disrupting the whole actual network. Then network security is also important. we need to provide a better security to the network, and then in this case network topology helps in understanding how these devices are connected and what is the situation of the security. So, it is very important to consider network topology if we want to have a high performance, if we want to have a good reliability of the network, along with high scalability and security as well. So, in this lecture we have looked into bus topology, then ring topology, tree topology and hybrid topology. We also looked into why actually this topology is it's important to be looked upon. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next lecture of this computer network series. Till then, take care. Goodbye.